Hey everybody, Scott Roberts here with Explore Scientific with Jerry Hubbell and Kent Marts, and we are all happy to see you here this Tuesday. You have made it all the way to episode 19 of the OpenGOTO Community Live. And we've covered all kinds of topics, everything from showing you how to use Explore Stars on all the different flavors and how to install things like Stellarium and use that remotely, and just answer lots of your questions and enjoyed seeing your images and have just had a really great time. So today we're going to cover some things. We're going to go over what is the PMC-Eight itself, and we're going to talk about some of the feature requests that people have been putting on the enhancement list. So we're going to make that a regular thing to kind of discuss each one of those things, to kind of work them out and see how people might really actually respond to those enhancement requests. People do ask us all the time to make this little change or that little change, but that doesn't mean that everybody likes that kind of idea. And sometimes there's some golden nuggets in there. So we're going to go through that and try to go through that whole discussion process that we would normally do with the product internally. That wouldn't be something that normally we share with the customer when we're developing a product. But the PMC-Eight's different. This is user developed. And so, and that's an important difference about this project and how we perceive that GOTO should be used by the world of astronomers. So why don't we start
Right.
with, what is the PMC-Eight? Jerry, is it an all-in-one computer like the ASI Air or
Right. There's some a little bit of confusion. I know I've had these questions in the past. What people get the nice big enclosure for the Exos 2 and the G11 mount. We've got this nice aluminum enclosure that's kind of looks like a router. It's got some connectors on it. It looks like a single board computer system. It is a single board computer system, but it's not the kind of system that it's a general purpose single board computer system.
I have one right here. Okay,
It's
so
a right.
people see other devices, you know, and maybe, I don't know, it does look like a single board computer system for a telescope. You'll see
Right.
these
It
kinds
looks
of things.
right. It
But
looks very much like a general purpose computer system, but it isn't a general purpose computer system. It's actually
very special purpose.
a motor control system. It's a piece of instrumentation, the way I like to look at it. It's been designed to be very robust and very reliable, but it's a dedicated instrument, is what it is. It's designed specifically to drive a two-axis motor system and we applied it to a telescope mount. So that's in its name. It's called a precision motion controller because that's all it does. That's all it cares about. So in that regard, you cannot load programs onto it. You don't have a GUI Windows type interface to it at all. It's a
No,
command line interface. It takes commands that are specifically geared towards making the telescope or the mount move, or any stepper motor system move, because it's really more generic than even an astronomy mount or an astronomical mount. It's basically, just as it says, a precision motion controller that can be applied to any device that runs on stepper motors. It could be a robotic arm controller very
could
easily.
be, could be. In
It
fact,
could be,
Jerry, you and I talked about, some,
yeah,
students were making a robot that they could use the PMC-Eight to control it with.
that's right,
Hmm.
exactly. So that was the source. That's the level I wanted to design this system at, and that's what Scott and I discussed very early on as the approach to our astronomy mount controller. Since that's the case, it uses a very special type of processor that's called a microcontroller. It's called a microcontroller versus called a general microprocessor because microcontrollers are designed to typically not run an operating system. Okay, it's like an embedded system. If you've heard the term embedded control system,
Yeah.
it's an embedded processor that's you can load. It runs firmware, but the firmware is coded to the level of the hardware. Where the firmware I created in the PMC-Eight is a signal generator to create the signals necessary to drive the motors the way I want it to work. So in that way, it's a very sophisticated signal generator, as opposed to a processor that drives LCD display or keyboard, or any other type of mount. Now that doesn't mean we do have a serial interface to that processor so that we can send commands and receive data from the outside world. Send data in from the outside world and receive the operations or real-time information from the controller. But this processor is actually special in terms of microcontrollers also because it's got 8 separate cores. It's like an 8-processor microcontroller. It's called the Parallax Propeller chip. And each of these microprocessors has its own dedicated task that is totally independent of each of the other tasks that are running on the microcontroller.
Now, why is that important, Jerry? Why is it to have all these independent things running?
So there's a couple of reasons I presented using this processor, this microcontroller to Scott, and one of his key requests was reliability and failure modes. So when you talk about failures, everybody has seen where you get the blue screen of death on a PC, and other processors that are used typically on hand controllers or on other even the standard microcontrollers that you run they're interrupt driven. That means that multiple tasks are running simultaneously in the same processor. So what the processor does is it switches from one task to the next.
Like a fry cook. He's making eggs over here. He's making hamburger patties over here. He's doing this.
Right. It's one guy that's doing everything. He's good jumping back and forth between
right.
tasks.
And it's how fast he can do that, right?
Right, exactly. And
versus
sometimes
having this guy just making eggs, that guy making hamburger patties, right?
Right. So think about this one guy doing all these things, and he gets hung up on one of the tasks because he spilled the milk, trying to pour it into the eggs to stir up for scrambled eggs.
Right.
Now he's got to handle that, right?
Yes.
And he can't handle all the other things that are trying to go on real time. This is a real time system, right? We want to monitor it and operate it real time. So if you've got an interrupt driven processor that gets hung up in a task, you're stuck. Now it's frozen, and everybody's seen that, the thing being frozen. So that's what this design mitigates. Okay, so you've got these 8 processors. We've got 2 processors that run full-time, dedicated, one to each motor. We've got one processor running the command interpreter, where it's looking at the commands coming into the serial port to say, okay, I want you to do this now, and then it sends it and sets the parameters to say, okay, I want to do this. And the way it does this with each of the separate tasks is each task could fail individually, but it won't fail the system. So even if a motor driver chip failed, or if the processor even hung up on that one task for the motor, you could still see what was going on because the command interpreter would still give you the information. That would not fail. If, let's say, the command interpreter failed for some reason, the motors would still be tracking. They would still be driving. You wouldn't have a mount that would freeze up and stop tracking. You know what I'm saying? So you got this independence of all the tasks. And there's other tasks in there that are kind of monitoring things. But what we call that, the other thing about the task is that it runs a fixed list of instructions in that processor. That's a deterministic way of running the system. That means once it's started, it's going to run that way all the time. You know exactly how much time it's going to take. Mm-hmm. It's very deterministic in its response. You don't have anything coming in interrupt it or to make changes or to make it behave differently. It's always going to do the same thing all the time, regardless.
Mm-hmm.
One other feature that allows us to use all these 8 processors all at once is we've got a shared memory space that each of the processors has access to, and that's where the global memory, that's where the global parameters for the PMC-8 live, in this global memory space. So everybody has access to the current motor position. Every processor has access to other information that's needed to understand what the system is doing. Every processor, like for example, when a new command comes into the command interpreter, it puts a message out on the global memory, and then the motor task can say, oh, look, there's a new position to go to, or there's a new thing that I need to do.
Yeah.
It looks at that and says, oh, okay, I know what to do now. It uses that through the global memory or the shared memory space. Each processor also has its own internal memory for its own local variables and local process to use. So that's the architecture of the PMC-8. It's totally different than any kind of general purpose computer where you can have a storage device where you have programs that get loaded into memory, and then it gets executed on the main processor and you can run multiple tasks all in basically the same memory space. It's all one contiguous memory space, but the processor jumps around like the one man guy that's doing 10 different things or 100 different things, one after the interrupt. So you got priorities. You run stuff first, and then you got interrupts to do other things. That's kind of that's the big difference between the two systems.
Yeah.
And Jerry, that makes it very robust, correct?
Right,
And
robust
very
in the
reliable.
failure modes and robust in the behavior, and it's very fast. That's why it's when you're on the tablet and you hit a button, that's why it immediately starts to move. I don't know if you really pay attention to that. That was a prime requirement that I had, that I want it to act like a hard button on a piece of wire that's feeding the processor. When you hit that button, you want it to immediately take off and do what it's done. Not like a camera where you hit the shutter button and you got to wait a quarter of a second or whatever for the shutter to go off. You've all experienced that, where you have a delay in the shutter.
DSLRs.
Yep. Right. You get a delay. I wanted no delay in that, and that's pretty much, we've been able to achieve that.
Okay, so Jerry, we've got a question from Space Time with Robert. Hi, Space Time with Robert. That's weird. That's weird. Your parents gave you your first name as Space Time.
Space Time.
So what's something that would make this system fail? And then we have another question from Wolfgang, but go ahead and answer that question first.
So there's several failure modes in terms of the electronics and the failure modes. You could have one of the driver chips fail for the motors. Okay. Now we do have there's a fault detection system on the driver chips for over temperature and over current protection on the driver chip to the motor. We also control the motor current and the firmware to the driver chip. So if the motor were to fail, if let's say the motor windings decide to short out for some reason and it started to draw too much current, you'd have an overcurrent flag that would come up on the hardware on the driver chip itself, and that would report back to the CPU, which I monitor. And so that would flag to me in the firmware that this motor has failed, basically.
Mm-hmm.
And that motor would just stop, but the rest of it would still continue on. You'd still be able to query to see what the status of the system is. You could query the position of the motors, and the way you would detect that at a higher level is that you're continuously looking for the new position of the motors, okay, to display it. Now all of a sudden, let's say you have this motor chip failure or the shorting of the winding, let's say, it would propagate up into the return value, position value for that axis. Let's say it's a deck axis motor that failed. You would start to see now all of a sudden, or the RA axis would be better. You would see that the RA axis stopped moving, and you would see it on the mount, and you would see on the indication on the display
So if the
that the
deck
motor is
motor,
no longer
if the
moving.
deck motor failed, you'd see the RA motor fail too.
Well, no, they're separate. They're totally isolated
Okay,
from
so
each
you
other.
said if the deck motor failed.
Yeah, I'd switch from the deck to the RA
Yes,
because
you
the RA is moving and the deck isn't typically. The deck is stuck. So that's why I switched
Okay,
it.
all right, so the
He
deck
did.
failed,
He
all
did.
right, okay.
Jerry didn't hit the clutch before he shifted gears.
Yeah, right. I just switched directly
He
to
does that on
RA
his
because
sports
RA is
car,
moving.
yeah.
In my head, I realized RA is moving, deck isn't, so you're not going to see any difference in deck. But the RA, so let's say that, for example, the RA
Okay.
motor failed and it stopped. And you may not detect it initially at the mount because if it's tracking, it's moving very slowly, so you might not notice it until you see the image come up, or if you're looking through the telescope, all of a sudden you might see the star start drifting, and you would see it at the display. The display would say, "Hey, my position hasn't changed."
Mhm.
So
Okay,
that's
so-
kind of a failure that you might
Have
have.
we ever had a failure like that come in,
No,
Kent?
Not that I know of.
Yeah,
not like that.
The failures we've had come in have been generally a internal connection to the Wi-Fi antenna gets disconnected, or there's a ribbon cable that gets disconnected, and
okay.
that's been addressed
It's
in
almost
future
like you could take the cover off and
Yeah,
pull the ribbon cable off and stick it back on and,
correct. So,
yeah.
yeah, right.
Mhm.
Right.
know-
There's actually an iXS 100 has internal cable where the Exos 2 and the G11 box doesn't have any internal cables other than the antenna cable. So there is a motor connection cable inside the iXos 100 for the RA
Yeah,
motor.
And we have had one where the motor cable got into the deck axis and got hung a little bit and created a problem with that. Was only that's a one-off. That's not
Yeah.
happened.
Wolfgang Drakes wants to know, uh, he's got a question about the box. Is it similar as the parts inside the iXOS 100 mount?
The
Yeah,
the
so
PMC-Eight,
what's different about this?
yeah, yes, it's the same PMC-Eight control system, same design. It's a totally different board design. There's reliability features that are in the big board for the Exos 2 and the G11 that aren't included in the iXOS 100 in terms of thermal performance and in density of the circuitry and the trace width. So I made the board bigger initially to make it very fault tolerant for wide temperature ranges. We've got the aluminum enclosure, which really manages the temperature quite effectively. The traces that are on the circuit board are bigger on the big board than they are because I wanted to have a lot of margin in terms of the general design of the system and how robust it is.
Yeah, so
now,
this is like the pro version, okay,
right,
which is what we came out with first.
and they're all mil-spec parts.
Yep, right.
So, talk about the effect. One thing we see, not fairly regularly, but periodically, is a low current. They're trying to use a tip that's not right, or a power supply of a battery power supply of some nature, and it works other things, but then they plug it up to the PMC-Eight and it has low current. What's up with that?
There's yeah, let me quickly just talk about the small board real quick. So what I took as a big board, I crammed that down into a quarter of the size. That's circuitry basically, and that's what's in the iXOS 100 without the thermal features that has, or the bigger traces. So that's the difference there. But in terms of the motor current now, or the current, the power supply, the battery. So I think what you're talking about is that lithium-ion batteries. You buy them like our battery pack. They provide 12 volts, but they can get they can discharge all the way down to where you have a 5 volt. If you got the 5 volt USB port, you can charge your phone, but it'll draw the voltage all the way down from 12 volts down all the way down to 6-7 volts. And you have the full capacity of the lithium-ion battery, which is whatever, how many amp hours or whatever it is. But that doesn't apply to the PMC-Eight because the PMC-Eight requires a minimum of about 10.6 or 10.8 volts. So you can only draw down a battery pack down from 12 volts nominally, 12.2, down to about 10.8, 10.5 before it fails. Because the voltage regulators, we use a 10 volt voltage regulator to drive the motors, but there's a little bit of margin there that's required for the power, for that power regulator. So you have to have about 10.5 volts minimum on the main power supply before it will work reliably in the power. So once you draw the battery down, as the voltage drops, to maintain the power to the motors, it's going to draw more current, a little bit more current off the supply. It's going to regulate that current into the motors on the driver chip, but in order to supply that current with at a lower, to provide the voltage at that current level, you're going to draw more current as the voltage drops off the lithium-ion battery.
Is this polarity protected?
Yeah, there's a reverse polarity MOSFET transistor on the board to keep you from making a mistake. If you wire up your own power supply and you plug it in and the light doesn't come on, then 9 times or 100 times out of 101 times it's going to be because you got the polarity wrong. It's not going to be a failure of the board. You might think the board's failure and you've wired it correctly, but that's not the case. You need to check your polarity on your connector.
I had a customer that had been using, I can't remember if it was Exos 2 or a G11, I can't remember which, but had been using a well-known brand of power supply and kept having grinding noises, which is the torque limits of the motor letting go. And so it doesn't tear up the motors, doesn't tear up gears. The motor just sort of hops. And when he finally said he was using a power supply, I said, do you have the AC adapter? I mean, you've got electricity in your observatory, right? And he's like, yeah. And so he dug around. In about 5 minutes, he found it, and he plugged it in. And we set it up, and it slewed. And he said, my God, that thing sounds beautiful. and he literally, I mean, he'd been doing this for like a year, and he literally basically started crying. I mean, he sounded emotional about the situation. And it all came down to...
Wait a minute. He started crying?
He had an emotional reaction.
Oh, okay.
I mean, I think he probably brought tears to his eyes because he literally was almost
Well, that's
speechless.
good. That's a good kind of happy.
Yeah, it was. It was great kind of happy, except it's been a year trying to fight with this, and all it was he just had electricity, and he just thought his, I don't want to say the brand name.
No, don't say the brand name.
The power box that he had was all that, and so he then turned around and bought this, which is our power supply,
and Nirvana, right?
It's going Jesse.
The one thing to realize, I talk about when it stops working around 10.5 volts, but you'll start to see where it starts to eat into the regulator, where the regulator can't supply enough current because the voltage is too low, and you'll start to see where it will start grinding maybe on one motor, not both of them. It might start to make a little bit of noise on one motor because that not quite enough current is being supplied, even if the regulator is set, even if the driver chip is set to provide that current, it's not going to be able to do it. So it starts to, that's a graceful failure. That's the kind of failure modes that we want to see on the system. We don't want to see a permanent lockup all of a sudden. We want to see graceful failures where it starts to have degraded performance. It's very robust that way in terms of the design, so that now the flip side of that is if the failure is too subtle for you to notice, it may take a while for you to detect it. But again, that's probably a good thing instead of being out, especially on a remote operated observatory. We built this thing, we designed it for a remote observatory. We want to be able to
That's right.
have a failure and still be able to shut it down or to put it in a safe position. You don't want it to just lock up where it's at and die all of a sudden.
Right. Right.
So, Jerry, you called it grinding, and that's the term that people use when they call customer service or post on the group's IO. And if you're not a member of the group's IO, you need to join that group if you're a PMC-Eight user, because there's a mountain of information. But they'll call it grinding. It's really not grinding. I touched on it, Jerry, but why don't you explain what's going on?
So what happens is on the motor windings, there's two sets of windings, two phases that are balanced or that push against each other to position the stepper motor in a certain increment, and we're microstepping it, so it's even finer than that. But you basically got these two separate windings that are positioning the rotor of the motor, the shaft, and it's a very precisely controlled signals that do that. So what happens is if you lose it, the current drops, then you don't have enough current or force basically to move that rotor. So it sits there and ratchets between two different positions. It sits there and tries to move, and then it jumps back, and then it tries to move, and then jumps back. And that ratcheting, I call it a ratcheting also. That ratcheting is the sound that you hear. It doesn't have enough motor current to overcome torque.
Is it tearing
required.
up the motor inside? Is it is it going to burn up the electronics or?
No, so it's actually so typically when you think about burning up electronics, you've got too much motor current that drives it, and that's what happens with DC servos. Is you're overdriving this thing, and it's got one force. It's got a required torque, and it's really pushing it hard to overcome this blockage. Right, you're providing more and more force on a servo motor to overcome this stoppage.
Yeah.
Where it's the opposite on a stepper motor, where you have less motor current to overcome the torque required. So you've got a minimum torque that the frictional and inertial load that the gears need to move accurately.
So
if you don't have enough torque on your motor shaft to overcome that required torque, then it's going to sit there and just ratchet. It's not going to have enough to push on anything. It's very safe. It's not moving your motor, or it's not moving your gears at all. It's not doing anything except saying, I don't have enough strength. That's basically what it is. I'm not strong enough anymore.
Whereas the DC motor is going to sit there and grind the gears down.
They're going to muscle up. They're going to be like these Arnold Schwarzenegger trying, I can move this thing.
and that's why you went with what you went with.
Like it's trying to pull a tree stump out of the ground or something, right?
That's right, exactly.
Yeah.
That's right. Even though before it was a little tree, now all of a sudden it's got this big root, and I'm trying to yank it out, even though it shouldn't be done.
Yes. Yeah.
So, Jerry,
I'll say that we wanted to have this because I find absolutely no joy at all in having to just replace electronics. That is just not the way to go. You want something that's really reliable. It's going to stick with you out in the field. I wanted something that if we had to, there was an emergency, we'd stick one of these things in the box and ship it out to you. So now that's not going to be possible on the iXOS 100 because we had to fit everything in this very small space. And so that's part of the deal with that. But this system, if you're really looking for, you're going on an expedition. You're doing, having worked in this business for so many years and worked in retail and worked for another telescope manufacturer and all the rest of it, I can tell you so many stories about guys that were taking their dream vacation to one of them. This goes back when I was about 25 years old, and the guy who took his dream vacation to Ayers Rock in Australia. And he gets there, and again, we're not going to bring up brands or any of the rest of this stuff, but what happens is that the motor inside of his mount fails, okay? And he's out in the middle of nowhere, absolutely nowhere. And it was an impossibility to help him, So sometimes astronomers go to these great distances. They go on travel, or they're in really remote areas in general, even if it's a couple hours away from the house. You know, they want to be able to get the parts that they need, get them quickly, and and to have equipment that they buy, it's something that they can actually rely on. I want that for myself, and so that's why we're building them this way. Some people, I mean, when we started down this path, there were people that said this is overkill. What you're doing is it's too much. We don't need to
Hmm.
have processors that are going to be serving just one function, when a processor could do many things. But this is the way to build in reliability. And there's other equipment, other instrumentation that require this kind of discipline, right? I mean,
Oh yeah.
you're from the nuclear power industry, right?
Oh
So
yeah.
how
Yeah,
many how
exactly.
many
Redundancy and
what's
diversity
your
are the key
margin
words.
for error in a nuclear power plant, Jerry?
There isn't any.
Right, zero.
There
It's
really isn't
zero.
any. So yeah, it has to work. So you build in reliability is based on, it's called defense in depth, where you have redundancy, you have multiple channels to feed certain parameters, you have multi-channel parameters, and then you have diversity, where you have design diversity. So we have analog systems for controllers, and we also have a digital control system that do the exact same function, but they're totally different in their components and their layout and the way they're built. And you know that digital systems also have diversity, where you have two manufacturers provide an identical digital system that do the same exact thing, but they're totally different architectures. So that's the kind of diversity we're talking about there. Now, we've done in this reliability design, we've done it based on architecture and in terms of dedicated processors and simplified. I would say the firmware is very basic and simple. For example, the motor driver, the processor that runs the motor driver that's dedicated to that, there's only the loop. You got the initialization code, and then you've got the loop, that all the instructions that drive the motor that create these signals I was talking about. That's about 20 lines of code.
That's it.
So,
That's it. 20 lines of code.
Yeah.
so I want to give a
It's
shout
not
out.
200 lines or 500 lines of
Or a
code to make the
thousand,
motor do what you want.
whatever.
So I want to
So
give a
somebody
shout out
wanted
real
to
quick.
know, wait. So what happened to the guy in the middle of nowhere with the bunk motor? Did he get a new mount? You know what the answer is? He was out too far, and no. Okay. So this dream vacation that he saved up all of his money for, okay, flew to Ayers Rock in Australia from California. That's where he's from. Uh, he couldn't do anything. So in his mind, I'm sure his vacation was ruined, so, which is really too bad.
Mhm.
Yeah. So okay. I want to give a shout out to David Ballantyne from, I'm going to butcher where he's from, but I'm going to try it. Missapolistic, Cree Nation, Manitoba. Hey, David, good to have you with us.
Right.
We've got some regulars: John Adler, C. Steeden Top, Bob Runyon, Dusty Haskins, Scott Roberts is watching.
Yeah, that's right.
Uh,
I'm watching
let's
three different channels right now.
Gary Palmer, who is
Right.
watching today, is Solar System Imaging. He's watching on YouTube. Mr. Thump is with us. And by the way, Jerry, Mr. Thump noted that it sounds like you need to change your smoke detector battery.
Yeah,
Yeah,
well,
he's been told that for years now.
yeah, you guys got to get over that hump.
So I don't hear it anymore. I literally don't hear it anymore.
Well,
Okay,
Jerry certainly doesn't hear it
no.
anymore.
And Wolfgang did have a question. When the mount is in park position,
Yeah.
normally it's pointed up at Polaris. The home position is north in Polaris. How do I change the park position?
All right, so this is something there is a difference between park and home. So default condition is park equals home. Okay, that's the standard factory default position that most people use. Home is defined, always defined as the north celestial pole or the south celestial pole. depending on what hemisphere you're in. That's home is home no matter what, right? But park is where you decide you want to go. You could go, across the street and park, or you could go, across the state and park for a couple days. But park is park, and you can position it. The way you do that with Poth provides a nice feature to set the park position in the profile of the ASCOM driver. So basically, you would go and Poth and drive it to a position, and then there's a button under the setup window that says set park.
So if you had,
Yeah.
like, let's say a roll-off roof observatory that came
Right.
down very low, and you needed to maybe not have your telescope up on top, but turn
Right.
sideways,
Hold it flat.
you
Yeah,
could
you
do
want your
that.
horizontal. You want your counterweight bar horizontal and it pointing at the
And the
horizon.
telescope laying as level as possible, so that you could close the roof if you wanted to do that.
So
Right.
that might be something to show in a future episode, how to set that in
Yeah.
ASCII.
Sure.
Yeah, we could do
We can
that.
do that.
Yeah.
We have some
Now,
other topics here.
yeah, we do have a lot of stuff.
Yeah, okay. So
We're
there
already
was
half an hour into
a
this.
couple of feature requests, okay? We've been telling people to put in their feature requests. And one of them is finding a spot on the mount or putting a spot on the mount for precision leveling, for people who want to, dead on level their mount with like a larger bubble level or something.
Right. It looks like we're looking at Kent's chest. Oh, there he goes.
I was reading a message from Gary Palmer.
Oh. Yeah, so flat spot, what do you think about that, Kent? How can we this is a feature that people are requesting on how do you level the mount. And we've talked about that in the past, but one of the things that we've talked about, we got a feature request, was to provide spots on our mounts to be able to put a level to know that it is level.
So, those are hard to build in. One way to attack it is, and Jerry's testing me to see if I paid attention. I know what's going on here. If you're in the park position, the home position, and it's pointed at Polaris, counterweight bars are vertical up and down, you can go into the RA and deck coordinate system in the app and tell it to move 6 hours into the future, which is 90 degrees, and it will rotate to 90 degrees. And then you can put a level, and what I've done is take the counterweight rods off, or counterweights off, and use the counterweight rod to level it. And so you literally will move it until you get it level. And then, as a test, run it 6 hours into the past to verify that it's level on the other side. And then if it is, you can then park the telescope, and because you physically moved it, the motor counts didn't change. So now it's going to rotate the RA back exactly to the home position at a zero count. And at that point, then on the Exos 100, and this is where this got developed, because there's no of those little triangular interface marks, take a piece of, metal Sharpie or piece of tape, put it across a gap somewhere, and then cut it. And now you've built your index mark. And so now if you've lined up right there, you've got it exactly 90 degrees from horizontal. So it's now 90 degrees perpendicular. And you can execute the same sort of command with the telescope as well, and use it to level the telescope and then run it back to the home position. Somebody hacking in right there?
No, I was just
Okay.
checking something.
Okay.
Yeah, we're simulcasting, and we now have a Twitch channel, and it actually worked this time. So
Good.
Oh,
So,
good.
Jerry, did I pass the test?
Yeah,
okay,
that's
so
a good
cover
explanation
it
of what
one
we can
more
do
time.
now, but we need to,
Cover it
the
one more
feature was to
time.
put it on the, I'm sorry.
Cover it
What's
one more
that?
time, Kent. On how?
Go over it one more time.
Yeah, on leveling.
Okay. So this is generally for the Exos 100, but it will work for the Exos 2, iExos 100. It'll also work with the Exos 2. you put it in the park position, and it's in the app. I've only done it in the app. There's a way to do it through ASCOM as well. But you, and I don't have a tablet here close, you go into the coordinate command system and look at, I look at the sidereal time, and then calculate, I'm going to add 6 hours exactly to that. And a few seconds or a minute doesn't matter. And so you're going to then put in that sidereal time.
Actually, that's not it, Kent. I'm sorry.
Okay, go ahead.
You're positioning. So when you're at
LMS.
when you're at the North Celestial Pole, you are 6 hours away from LMST.
Right.
So you put in the LMST.
Right.
Because that's the meridian. That's when the counterweight bar is horizontal. That's when it's horizontal, is when you're pointing near the LMST.
Okay. And so at that point, then, it's 6 hours into the future for the LMST. And you put in the 6 hours ahead, you tell it to go, and it'll rotate the RA from the counterweight position up and down. It'll rotate it to horizontal, and you put a level here on the counterweight bar, and bubble level it, move it, and get it perfectly level, and then program in the coordinate system 6 hours into the past, and the RA will turn 180 degrees.
Got it.
And now you can put a bubble level here and make sure it's really perpendicular. And then when you park the telescope, because you know it started from perfectly level 90 degrees, you now know that this is perfectly perpendicular to the horizontal, and on the RA axis, you can put a tape or a metal Sharpie or whatever across it, and now you've created index marks. So this gives you a good place, because the better accuracy you are starting from the same place every time, the better you are in getting polar alignment and tracking and those things. And so this is a way to start out from a very known precise position in RA.
Right.
And you can do it in DEC as well.
So that's currently how you can set the level. Now, the feature request says what would we need to change on the mount to create a flat spot, or to do this on the mount itself? So right now we have a bubble level. So it seems to me that
it's not that there isn't a bubble level there, okay? But we're talking about doing something that's high precision, okay, as far as
that lets
bubble
us
level.
create a flat spot, basically machine a flat spot on the mount that we know this has got to be level to level the mount. And it's big enough to place a nice level on.
Would you have to have that in 2 axis? Because level north and south is not level east and west. And the reality is you need 3 axis, really. I measure, when I put my tripod down, I measure in 3 axis, just to make sure that I've got it level.
All that matters is north, south, and east, west, really. That's all you care about. So those are the 2 levels that you're really worried about. If you get those 2 right, then everything in between will be right.
There's a question about the G11. Does it have built-in bubble levels? Actually, it has 2 very nice built-in bubble levels. So you've got one that is going to be on the deck axis, and you've got one on the azimuth axis too. So
I've got some experience using those levels based on the park position and coming back from a sync position in the sky back to park. There's a little bit of stiction, that I call it, on the bubble itself on the deck axis, indicating horizontal or vertical on the counterweight bar. You have to tap it, and sometimes it doesn't move. So I'll basically what happens is I'll finish the session up. It's been a while since I tested this, but you'll finish the session, you'll do a park, and you'll bring it back to park position, and the bubble won't be straight. And we know our pier is absolutely level because we took a lot of pains to get that. We've got adjustments on it to make that level. So even the bubble levels on a G11 might not be
Yeah.
perfect. They look good. I mean, they're awesome bubble levels, and they
They're
get you very
beautiful.
Yeah.
close.
And Jenny, on the G11 that I have here in my office, on the top of the pure cap, not actually on the tripod, but on the pure cap, where the mount sits on, okay, are two bubble levels, one for north-south, one for east-west, okay? And then there's another bubble level up on the deck axis.
Yeah, right.
So there's three bubble levels on a G11. Maybe older models didn't have it. That's possible.
That's
Does,
very
does hers
possible.
not have it?
Yeah,
She
that's
says
what
it
she just
doesn't
said,
have it.
not
Oh,
mine.
Yeah,
okay.
not mine.
The one that, the one that we have in the observatory have them.
Yeah, yeah. This one behind me, that one has it. So, um,
So that's the feature request, is to have a flat spot, and we're talking about levels today. We're really talking about cell phone levels is what people rely on to do their leveling with the bubble level. So I don't know if there's any good space. Where I would position a level where it's really important is at the dovetail plate, um, and at the axes right there. Where so you want it to be level when you have the indicators lined up on the axis for the index marks that Kent was talking about
yeah,
on the RA and the deck axis. When you have those set, if your tripod is level, you have your mount on top of the tripod, and you have your indexes lined up, you want a good level at your dovetail is where it comes, where the rubber meets the road.
yep. And on the nicer mounts, a lot of them have these. The G11 does.
Yeah.
Okay, and so what's our next subject here? We have feature request update or about the universal firmware, and there have been some requests there.
Yeah, so it's been a fairly long-term request. So right now we have two versions of firmware for people to load on their system. Um, Actually, four different ones if you consider the different ones we have for motor current values. So you've got a combination of the communications watchdog timer being enabled or disabled. We've talked about that in the past, why that's needed. That's what's one switch, and then the other one is the motor current. So I've got standard motor current versions of the firmware for the G11 and the Exos 2, and then I've got beefy motor current settings, which are good for observatories if you want to have a really stout amount of motor current driving your mount, and you're using an AC source of power. It's not for battery use because it uses a lot more current, not a lot, but significant amount more current that'll drain your battery much faster. So you want to go with the lower motor current values that work just fine. There's nothing wrong with them. It requires your mount to be balanced pretty good. If you're out of balance, if you're somewhat out of balance, and it's got to be fairly significant, you'll get this ratcheting that we talked about earlier, because the motor current supply is not going to exceed the torque required. So that's the low power setting for battery life, and then the higher power is for if you're in an observatory. So what I'm going to do, and then there's differences between, so there's a motor current difference between the Exos 2, the G11, and the iExos 100. Now, I'm just concentrating on the Exos 2 and G11 because they have the same exact hardware. I'm going to create one firmware that's going to handle the two different mounts for all the motor currents that you need and the watchdog timer. So there's going to be switches, switch commands that are going to be updated in the firmware to allow you to use just this one firmware on any of the big boxes that Scott showed earlier. In that box, that PMC-Eight model, which is the Model 2A model, all right, that's going to have just one firmware. Hopefully by the end of the year, I'll have this out where you'll just use just one firmware. Instead of having this list of firmwares, depending on what mount you have, it's just going to be one. that's going to handle all of it.
Life more simple.
It's going to make it much simpler for the customers, much simpler for us to maintain the code and all that. The iXOS, now I could apply to the iXOS 100. It's got a different Wi-Fi module, so now I would have to switch Wi-Fi modules as a command line to the PMC-Eight to say, okay, I know I've got the iXOS 100. I want to use the iXOS 100 Wi-Fi module. So that would be a switch between the iXOS 100 and the G11 or XOS 2 Wi-Fi module that's out there right now. So we want to get to the point where we just have one firmware for everything, and that's part of the things that I'm going to be building in.
Right. Okay. All right. And then there was a mention today. I think Kent, you brought this up. Alex Arjomand's how to use the XOS 2 PMC-Eight document that's on the OpenGOTO Community.io.
So Alex posted, I think yesterday, within the last couple of days, that he had documented every step of the way from getting his PMC-Eight, XOS 2 with PMC-Eight, and getting it up and running and starting to do visual assisted astronomy. He says he thinks astrophotography is a year or two in his future, but he turned that into basically a very long extended blog. He could have done this as a blog and then compiled it, but he's been taking notes and documenting literally everything he's done. And it's an impressive outline that is a decent tutorial for how to build a system like his.
Yeah.
Now,
I've got it up on my screen now.
There you
I shared
go.
that.
Yep. So, he's it goes into everything he's done, and for people who are wanting to have some idea of how this all looks, now everybody's system is going to be different. Different telescopes, they're going to like a different planetarium program or like a different, whatever, different camera, different finder scope, whatever it is. But this is a great outline, and this really shows, how the GOTO community is evolving and the participation. He didn't tell anybody he was doing this. He just sprung it, and it's received really good, response.
Right. One of the biggest features of this summary of his installation of everything, he's basically documented very well what he does to create his system. But he provides all these links in here. So this is a big resource for links for different things. He's got an overview. He's got links to the ASCOM, the driver, all the standard stuff that you want to use. And this could be applicable to a lot of different systems. And then and he goes step by step on what you do with the system, how you do it. You can see he's got pictures of things and the setup screens. He also, when we get past this, he's got, my dogs are going nuts all of a sudden.
I thought that was your stomach growling for something.
Yeah. So I don't know why they're fighting. They're fighting over food or something.
Yeah.
You guys stop it. So he's got this installation stuff here that I'm talking about, and then he's got a mount setup checklist, which is kind of cool. This is kind of, I go into this type of thing in my book, my first book, Scientific Astrophotography. I've got a lot of procedures in there, kind of like this. So it goes through each step and tells you what you need to do, which is really cool. And it's pretty extensive.
He took 2 years of watching on the PMC-Eight users group and has synthesized it into this 19 or 20-page document that documented every step of the process.
Wow.
The other major thing he's got here that I like a lot is he's got posts from the forum, different links on different things, and it's a good reference.
Oh, wow.
He really took an academic approach to this.
That's amazing.
Yeah.
Excellent. Well, great.
All right.
We need to send that man a shirt.
Well, I will work on that.
Yeah. That's excellent.
Okay.
Yeah. So, and then we have actually, I
Hey,
think somebody is actually watching right now. We have Wolfgang Drakes Astrophotography that we wanted to show. So he posted some images, and we wanted to share. We wanted to share those here with you as part of our sign off for tonight. So we thought that was a great way to go.
and he's using an Exos 100. Jerry, you working on calling that up?
What is it? You want me to call it?
Wolfgang's
Oh, yeah, right.
Astrophotography.
Wolfgang's.
So these are new images, and I think early images from his process down the lifetime journey of astrophotography. So
let me share that.
and so it was cool when I saw him pop up and saw who it was, and was hoping that Wolfgang, we were hoping that you were going to be on today so we could share these pictures.
There you go.
So what's he doing? Let's scroll up a little bit. He's got a Exos
picture?
100.
Yeah, he's got an Exos 100.
A Canon 1000D unmodified.
Okay.
A TS Photo Line APO 72432. A TS. What's TS?
That's the name of the company. I think.
What is it?
And for Telescope.
Is that Telescope? Maybe
Telescopia or something. I don't know. I can't remember.
A flattener, and he's using the MGen 2 standalone auto guider. Jerry, you were working on ways to integrate that with somebody, weren't you?
Well, I think I helped Wolfgang and other people that use this over in Europe. This is a very popular standalone auto guiding system that you have to have if you're using the ST4 port. It has to be calibrated to our PMC-Eight.
Telescope service in Germany.
Yeah, telescope service. So it's got to be calibrated. The ST4 port's got to be calibrated for that system. It's different than a standard contact closure, which is what we provide calibration for. So I worked with him and other users to provide a version of the firmware for the PMC-Eight that's custom for this auto guider system.
Able to bring those images up full screen or
let me see if I can. I'll zoom up on them. I don't think I can click on them.
They don't click and open. I see.
I'll zoom up on it, and then I can. Oh, there we go.
Okay, that's nice. Is
that better? Let me zoom up some more.
So he said the M31 picture was looking over the light pollution of Frankfurt am Main. So it was just rising in the east.
Mm-hmm. You definitely see the dust lanes. It's beautiful.
Yeah.
Yeah.
And not sure how much experience he has, but it's better than what I could take.
He's guiding. He's doing a good job. So
they're
focused.
30 years ago, this had been professional level imaging.
Yeah.
And not even that long ago, he would have had the cover of Sky and Telescope magazine. So
the technology and the skill level necessary and the studying needed has improved so much over the last 30 years compared to the previous 400 years of not imaging, but of observing and what you can do.
Right.
The feedback, digital closed the feedback loop.
When did film start, Scott? When did people? That was the first thing people did with film, was take an image of the moon.
First image of the moon
I should
was
know that off the tip of my tongue. I'll find it. One of the very first astronomical images was of course, the moon.
1840, Draper in 1840.
Yeah.
So I think there's been more progress in the last 30 years than there had been in the previous 100 and some years.
Oh yeah.
And it's been driven by digital because you get instant feedback.
Right.
You can previously I'd sit out in the night all night long with film, and I'd shoot a bunch, 36 exposure roll, go in the house, develop the plus X film, go, okay, let me try this. I'd go do it and come back and just keep iterating. Now you can take an exposure look, and very quickly close that feedback loop.
Oh yeah. Absolutely.
Mr. Thump 30 says, I've only ever used a hand controller. Is there any talks of introducing one for the PMC-8 system? Nothing against stepping up to full computer or tablet controls. Now, something that you need to know, I mean, and a very inexpensive part of this, I mean, the reason why you want a hand controller is so you have tactile feel, okay? We have buttons that you can attach to your tablet, and they can be operated with your gloves on, or you know, of course, without gloves on. But they work extremely well, and you know, there's just a few dollars for a set from Explore Scientific. So
And they're gamer buttons.
they're gamer buttons, exactly, and they have to work extremely well. However, will we ever have a hand controller? We do get requests for it. It is not an impossibility. I would imagine if we do have something, it's probably, you know, 6 months, 6 to 10 months away if we do it. So, and that really
The other
does
thing is
depend
that
on
it's going to be
demand.
different. If there's any hand controller that's on the PMC-8 system, it's really going to, it's our feeling is that it has to augment the existing system, not just replace it. So it would be used along with the Explore Stars application.
Right.
We're trying to drive the future, not the past.
Right. We want to bridge. We want to make it a bridge, is what we want to do. That's why That's why I think we decided we want to have the Explore Stars operate simultaneously with the hand paddle. Now, that doesn't mean you couldn't use a hand paddle by itself as a basic tracking mount. That's probably what it would be. But you wouldn't get all the features and all the nice enhancements that you get with the Explore Stars.
Well, once you start actually working with all the features that that you can integrate with the PMC-8, it's kind of hard to walk away from it, you know, because you start to have a very, very powerful system, you know. So to go all the way back down to I just want to track and write Ascension, uh, you know, that's a little tough, I think. It
Mm-hmm.
may be necessary at times, you know, but you know.
Well, the biggest feedback, and actually that guide that was created. What was the fellow's name? I'm sorry, I can't remember.
Mhm.
Uh,
Uh,
Alex, almost
Alex, yeah,
Arjomand.
yeah. We do offer a way to do a tactile feedback controller, and that's with the gamepad. There's a program called ASCOMPad that he uses, and a lot of our customers use.
Oh yeah.
That's a piece of software that connects to the ASCOM driver, and it's a Bluetooth driven ASCOM or wired ASCOM or gamepad that you can use with the system and have buttons and stuff right at the eyepiece. You don't have to be looking at your computer. But again, this is an augmented system that's available today. That's basically for a computer-based ASCOM system using the PMC-8.
Great.
Yep.
Mm-hmm.
Jennifer Shelley just wrote about the Xbox controller with ASCOM using a game controller or a joystick. And looking up a little bit, Mike Overacker, still have not pulled the trigger on the Exos 2 PMC-8. Well, Mike, I know a guy who can take care of that. I mean,
We're
give me
getting
a call.
close, though. We're getting close to being sold out. We've had
Yeah.
the industry, the telescope industry has been crazy during this unfortunate time during the pandemic. But it's allowed people to focus on their hobbies and it's given them people time to really dive into various aspects. You know, if you're an amateur astronomer, you got time now to really go and dive in on your astrophotography if you're at home, uh, and that effect has been going on worldwide. Sales by all the industry throughout Europe. I'm sure in Australia. I know it is in Asia and here in the Americas. It's just been very, very aggressive. So we are we're getting down internally to where we have just the last few of the Exos 2 mounts before we get our next shipment, which is going to be a little ways away. So right now, a lot of our mounts are out with dealers. So if you're thinking about upgrading, it was like when I had this epiphany. Hey, Scott, wouldn't it be great to go get a bicycle during this pandemic? I could not find a bicycle. Okay, I could not find one.
Even high-end bicycle shops.
Yeah, well, that's where I went. That's where I went. There, I mean, the place was almost empty. So I got lucky and I did get one. But anyhow, just a little bit of advice.
We are getting we are working on the IXS 100s right now. They're out of stock, but we should be able to have those to deliver
They're
here
coming.
sometime soon.
That's right.
Couple 3 weeks, maybe something like that.
Something like that. Yeah.
So Mike, Tim Meyer on YouTube said, "Pull the trigger. It is worth it. No pressure." But
thanks, Tim.
Yeah.
I know a guy.
It's probably not so humble opinion that we probably offer the best mount value in the market in terms of performance and price.
And we see that on comments from users who come to the PMC-Eight who have used other mounts and say, bar none, especially for the price.
Yeah.
They get quality stuff and great tracking and guiding.
All right, Jeff. We've been on the air for over an hour. Tonight, we have Dustin Gibson from OPT. He's going to be on with us live at 6 p.m. Central, so that's less than an hour away.